Hello children, hope you all are taking care of yourself against COVID. Revising daily modules will help to retain the information in you. Did you understand and complete the EVS1 assignment on different views of 3D objects? Today let us learn how 3D objects like landforms are represented on a map or paper. So let us begin. We know that different landforms are formed as the land is not even in all places. The height of any landform is measured from sea level, that is from the ground level on the earth. Look at this picture. The part which starts with light brown and ends in dark brown is above the ground, and the blue part referring to sea level is given in blue color. The next image shows a person standing below sea level, at sea level, and above sea level. In the last module, we learned that a map drawn on paper always shows two-dimensional drawings of three-dimensional objects. Remember this? The physical maps indicate different landforms like mountains, rivers, valleys or plateaus in 2D forms on paper. Their height or depth cannot be shown on a map. Is there any possibility to represent them in a 3D form on a map? Yes, there are methods that we can show on the map. Looking at the hills in the distance, we can see how tall and broad they are. But we cannot tell how much area or space they occupy on the ground. Like topographers, one has to go up and above the hills in a helicopter to see how much area or space they occupy on land. Topographers are the people who do the study of physical features of the land with the help of satellites, radar, and telescopes. In class 4, you have learnt that air is cold and the air is rare at greater heights. The height is otherwise called altitude or elevation. How can the elevation or height of landforms be shown on the map? It is impossible to show the depth of a valley or the height of a mountain on a map. We don't see pictures of mountains, plateaus, rivers drawn on maps. Instead, we see lines, colors which represent them. Such maps are called relief or topographic maps. One of the methods to know the elevation of landforms is the contour line method. For example, let us take the hills, a type of landform, and you know it is a 3D object. Look at this picture which is also given in chapter 13 of your maths textbook. Its front view is clear for us. Of course, we don't know how the aerial view or the top view of hills may look like. Now look at the lines drawn on them which show their approximate heights from the ground level. Here it is mentioned as 200 meter which ends in 800 meter. So the height of the smaller hill is 600 meter and the taller one is 800 meter. Look at this another image. Now tell me, what is the height of this mountain? Right, it is 3500 meter. The lines drawn to indicate its height or elevation are called contour lines. Let us understand this easily with the help of an activity, cutting the potato into half. Here you can see the lines drawn on a half-cut potato. Assume this potato as a small hill. There are 6 contour lines circularly drawn on them at different heights on all sides. That is, the first contour line is drawn at half centimeter height from the bottom or the ground level. the next line at 1 centimeter, then the third contour line at 1.5 centimeter, next one at 2 centimeter, then at 2.5 centimeter in height, and the last at the top at 3 centimeter height from the bottom or the ground level. So we know that the peak or summit or the tip of the hill is at 3 centimeter. Just imagine how these concentric circles will look when viewed from the top. Shall we try to draw its top view? Yes, this is its top view. The first line that was drawn becomes the border circle, and the topmost circular contour line drawn at 3 centimeter height in the first image is seen as the innermost circle in the second image. Since it is impossible to draw the landforms on a map mentioning their elevation or altitude or height, this method of drawing contour lines is followed. Now watch this video on potato activity to draw contour lines. So we have now learned to draw contour lines for the hill having one summit. What in case if the hill has two summits or two mounts? Let us try drawing contour lines for it now. Here we have taken another potato cut into half. But this time, the potato has two mounts. The front view and its corresponding top view of the potato is given here. We can see two different circles in the center, which tells us that the hill has two summits. Children, try this activity at home. You will understand better. Coming back to this image, how would the contour lines look when viewed from the top of these hills? Contour lines are drawn at 200-meter height, then at 400 meter, 600 meter, and at last at 800 meter. So the peak is 800 meter in height. The gap between any two contour lines is called a contour interval. Each gap or interval is of 200 meter difference. Take any two consecutive contour lines and subtract. That is, 400 minus 200 is 200 meter, or 800 minus 600 is 200 meter. So the contour interval is 200 meter. Do the contour lines overlap one another? No, they don't. They are parallel to each other. Here is the top view of hills having contour lines drawn on them. Look at this another image. Can you tell me the contour interval of this mountain? Yes, you need to find the difference between any two consecutive contour lines. Correct. The answer is 250 meter. For example, 2250 minus 2000 is equal to 250 meter, or 3500 minus 3250 is equal to 250 meter. Here is the next image. What is the contour interval of this landform? Correct, it is 20 meter. This is how a contour map looks, which shows contour lines of different landforms like valleys, hills, river, etc. In this image, we can also see more landforms like ridges, depression, mountains and ravine. Contour lines are drawn different for different landforms, which show different shapes and curves. A hill may have gentler slopes on all sides, or it may have steep slopes. A hill may also have a gentle slope on one side and a steep slope on the other side. Because of this, even the contour lines show differences. Let us learn about that now. Look at the contour map drawn for this hill. Do you notice that the contour lines seem to be nearer to each other on one side, and the lines are far away from each other on the other side? We understand that contour lines are seen nearer to each other on the steeper side of the hill, whereas on the gentler slope side, the contour lines are far away from one another. In other words, we can say that the contour interval or the gap between the two contour lines is more on the gentler slope side of the hill. So children, hope this topic is clear to you. Read and understand the textual matter and complete the assignments. We shall continue this chapter in the next class. Till then, take care. Thank you.